So great to see you at the last slot, last session of our today's KCD. And I have the honor to introduce you to Mark, our CNCF ambassador and a fellow KCD organizer, because he is the guy responsible for KCD Budapest. A warm welcome, please.
Thank you. Can you hear me all right? Okay, cool. So thanks for joining the last presentation, for holding out. My name is Mark. I'm a Cloud Native ambassador. I'm also a Dagger commander, whatever that means. Maybe it gives me the authority to talk about Dagger. But I'd like to start with a bold claim. CI/CD, as we do it today, is completely broken. There are tons of issues. But the biggest problem of all is that we don't even care about anymore. Like, we're so used to this status quo of long CI pipelines, of not being able to try things in our local environment, that we don't even care anymore. And in worse situations, we may even bypass the protections that CI pipelines give us to get something deployed quickly. So I'm going to talk about a couple of those issues that we don't really care about or don't have good solutions for, and we'll see how Dagger can provide a solution for improved and accelerated developer experience. And I'm pretty sure that most of these issues will be familiar to you, maybe just haven't realized that you have these problems. So maybe I'm not going to tell anything new to you, but just empathize with your pain as a fellow YAML engineer. So the first issue that almost all projects have is environment drift. And what I mean by environment drift, if you think about the different environments that you have in your software delivery pipeline, you start with the developer environment. That's where you code, write your software. And that's where the problems start, because if you have like different platforms you have to support, Linux and Mac, you have to install a bunch of dependencies and tools you want to use. Like, how can you tell me which version of Go these commands are going to install? Yeah, exactly. Like, for some people, it's going to be like 5 versions earlier. For some people who just joined the company, it's going to be the latest, greatest version. And those differences create friction, because for some people, some code may compile. Like, for example, I don't know, you started using generics and someone else uses an older version, it's not going to compile for them. So it's going to be some friction within the developer environments. And then we have a CI/CD environment, and in an ideal scenario, you will have some versions logged so that you know what's in the CI/CD environment, but this is already like a different representation from your developer environment. So you have to maintain a developer environment, and then you have to maintain a CI pipeline. And then you may have like other environments that you have to maintain. For example, you may have a Docker file where you build your software. And that's again, a completely different environment that you have to maintain. As you can see, it has a different Go version as well. So why is it a problem? It creates a maintenance burden because you have to keep these environments in sync in an ideal scenario. It's also, it can also introduce hidden bugs. For example, if you have different Go versions or different dependency versions, you may accidentally introduce bugs into production code. It also undermines trust in your processes. Like, I literally heard this a lot of time. CI always fails, just ignore it, deploy the code, who cares? And it creates onboarding friction. Like, people come and go on projects, and it's hard to onboard them when you don't have a clear description of your environments. So what's the solution here? Well, maybe start treating these environments as a single environment instead of different ones. So all of your developer environments, CI/CD and artifacts and anything else you have, just start treating them as a single software delivery pipeline, part of a single pipeline with portable environments between the different places. It's a place problem that you have across these environments. Now, I wish there was something that could provide a solution. It was around for years now. Can you guess what could be? Interestingly, ASDF always comes up when I ask this question, but that's not the answer I'm looking for. Like, what's the solution to move environments or package up environments and use them in different places? And it's a cloud native solution. Containers. So containers are a great way to package up all of those environments into a single portable thing and use it across these different places. Nix as well, but the learning curve is pretty steep, so that's not always a good idea. So if containers are the answer, why don't we just use Docker run everywhere? Like, why don't we just run Docker commands? Well, although it gives you containers, it doesn't give you the glue around the containers. It doesn't give you the workflows that you can work with. So let's put a pin in that. We'll come back to that, how Dagger addresses this problem. The other issue I want to talk about is that it's actually a phrase coined by the Dagger community. It's called push and pray. It's when you push something to a Git repository and then pray that the CI doesn't fail. And it looks something like this. You write some code, then you commit and push to your Git repository, maybe open a PR, wait for the CI to get triggered. What do you think the next step is? Well, first you have to wait for a long time, and then obviously it breaks. And the problem with this is it creates a really long feedback loop where you have to like write code, change something, push again, wait for the CI to do its job. And that's a really long feedback loop where you don't get the results until, I don't know, few minutes, 10 minutes, 40 minutes. And maybe it's a good thing. Maybe like from time to time, you need to stretch your legs, stand up and do some exercises, maybe go for a coffee. But imagine how much coffee I had to drink while I had this. It was crazy. So let's imagine an ideal solution. You write some code, you run the pipeline locally on your machine, and iterate. And you get the results, you get a much shorter feedback loop where you get the results much faster, and you can iterate to fix the problem. Maybe you introduce something wrong to the code. So you can iterate locally. So what we really need here is portable workflows. We need portable environments, but we also need to be able to glue these environments together and create a workflow that we can run, not just in CI, like it's not just a CI pipeline, but we want to run the same thing locally so that the developers can learn about either the mistakes or reasons that their code won't pass the quality checks that you have in place in CI as soon as possible. And you could run these anywhere, obviously, if you're talking about containers, where you can run containers. So that's the next thing that we will take a look at with Dagger. And lastly, I think the biggest problem with this whole thing is YAML. So on day one, you usually start with something like this. It's pretty simple. And then pretty soon, you will have like a huge YAML and bash and maybe Python monstrosity that no one wants to touch. If you touch it, it always breaks for the first time, and then you have to go through this push and pray lifecycle because you can't test it locally. You have no idea what's happening in there. The guy who wrote it already left the company, so you don't really know what's going on. Well, technically, you can run it with GitHub as well and CircleCI and a bunch of other providers, but in my experience, in most of the case, it doesn't work. So technically, you could run it. In reality, who knows? So how did we end up in this mess? Like, scratch your head. The problem is YAML is a data serialization language. It's not really it's good for declarative things, but CI pipelines are rarely declarative. Think about, for example, if you need to do a loop or a simple branching in GitHub Actions, how do you do that? You can't. You maybe use some action that does it for you. That doesn't count. See the footnote, it doesn't count. So YAML is not reusable. We can debate that at the party. It's not composable, or at least it's very hard to reuse pieces of YAML snippets. Obviously, all of those big providers like GitHub and GitLab have ways to package up pieces of YAML into actions and compose them into other actions. But generally speaking, YAML itself is not composable. I already talked about control flow. You can't really do loops and branches, or it's very hard. And it's also vendor locking. Like, you don't have a generic CI YAML language that you can use. It's always logged into GitHub or GitLab or Circle CI. And it's a problem when you have to do replatforming, and it happens more often than you think. Like when your company gets acquired, contracts are not renewed. It happens all the time. You have to move it between providers. So YAML is not a great choice of language for workflows. Yeah. It's not a programming language. So how about, and this is not a novel idea, how about we use a real programming language? And it's been done during the years. If you are familiar with Jenkins, Bazel, they use a language, well, in Jenkins it's Gradle, or what do they use? Groovy, sorry. I'm sorry, I'm not familiar with the Java ecosystem. So in Jenkins it's Groovy, in Bazel it's a language called Starlark, which is a Python-esque language. But if you are familiar with Bazel, you know that you need to be a rocket scientist to understand how it works. Like, there is always one guy at the company who knows how it works, and if he leaves or gets hit by a bus, then it's over. Like, nobody is going to know how to use it. And that's a problem, because from time to time, you need to touch your CI pipeline. You need to fix something, upgrade something, add something to it. And developers need to be able to change or work on their CI pipeline. So, and this is the novel idea that Dagger introduces. How about using a programming language that you already know, that you already work with? If your project is in Go, how about writing the CI pipeline in Go? If it's in TypeScript or Python, why not use that language that you already work with on a daily basis to write your CI pipelines? Because I think there is a .NET SDK in progress, but .NET is, it's a different ecosystem. I'm sorry? Well, yeah, Dagger tries to stay in the cloud native ecosystem. I don't know how .NET. Okay. So how about writing something like this? Like, it's not even real Go code, but it's Go-like. I usually work with Go, so this is something I came up with. It's pseudocode on purpose because I didn't want to spoiler how Dagger does it. But how about, like, have a simple build function? You can use it locally, build a binary, or you can use it in your CI pipeline during your release, and then compose that function into a container image building function. You can even extract this whole new container stuff into a separate function if you want to use it on your own machine. And it can take care of pushing to the container registry as well. So you can try it locally if you have to. For example, if GitHub is down, it happened more times since Microsoft acquired it. Yeah, what if your Git repository is down? How do you do hotfixes? So ideally, we would like something like this for our CI pipeline. And there is, of course, AI. Like, we write a shit ton of code with AI these days. Microsoft said, I believe, that 40% of the code that they write these days is generated by AI. And it's a good thing, right? Like we are more productive, we write more code. Um, but the problem is, well, it's usually AI slop, so you have to review it very carefully if it really works or not. And second, it puts a pressure on all of the manual steps in your software delivery pipeline, for example, code reviews, because now you have to review more code you're under the same time. And obviously, like, this gives a momentum to the whole pipeline, but the problem is that these days you either skip code review if you want to keep that momentum during the pipeline, or people struggle with mostly reviewing code and not actually working on something. And if you, these are some numbers from a research that a couple of companies did about AI adoption in different areas of the software delivery lifecycle. And as it shows, code obviously on the highest adoption rate, but CI/CD not very much. Obviously, a lot of companies use AI, but not in the CI/CD part of the pipeline. So what if we try to introduce AI to our CI/CD pipelines as well? How can AI help reduce that pressure that code generation puts on, for example, manual reviewing? And you could do a ton of things. For example, the AI could review your code and make sure that it's in line with your coding standards. If you have a document that details your coding standards, AI could review that code that you submitted in a PR so that real human doesn't have to worry about how you do ifs or branches or loops. It maybe it could fix tests if there are some breaking tests. It could figure out what's wrong and submit a pull request to your pull request and fix those tests. Or maybe it could update vulnerable dependencies. It could run some security scanner and make sure that there are no vulnerable dependencies in your code. And all of these could be done by AI to alleviate the pressure on human reviewers. But how do you do it? Like, has anyone here in the room used AI in a CI/CD pipeline before? No, well, I did, but looks like no one has. So how do you do it? Do you do with GitHub Actions? Well, you end up with this whole long feedback loop with push and pray. So that's not really ideal. You could write some custom scripts, but then we are back with that script monstrosity that you have in your GitHub Actions pipeline. So how do you do it? So again, portable workflows are a requirement for this to work. So you need to be able to run the same pipeline across environments. And you need some language or some solution where you can integrate AI directly into the workflow without having to write like manual scripting or anything like that. So these are the 4 problems that we have these days. Obviously, AI, like, it's skyrocketed in the last 6 months or so. So these are the 4 big problems. Obviously, there are other issues as well, but these are some of the big issues with CI/CD that contribute to why CI/CD is broken today. And again, the ideal solution, we need portable environments, we need portable workflows, we need to be able to write those workflows in a language that we are already familiar with, and we need to be able to integrate AI into these workflows without any friction. And as it turns out, that's exactly what Dagger does. So in Dagger, you can write so-called functions. I'm not calling it workflows on purpose because you can do much more with functions than with workflows. But you can write these functions, basically workflows as code, in the programming language that you already know. You'll see some examples. You run these workflows in containers, so the workflow itself runs in a container, but you can also launch your own containers. So you can have like a separate build step where you build your Go program. You can have a separate step where you run tests. So basically, you can orchestrate containers using the SDK that Dagger provides. So you can provide sandbox environments to all your build steps. And obviously, you can run them anywhere where you can run containers. And you can also use these functions as AI agents. So you can integrate these functions back to other functions to use as AI agents. We'll see how. So here is a simple example of a Dagger function. What you can see here is we create a container. That's where we're going to build our Go program. And the syntax itself should be fairly familiar. It looks a little bit like Dockerfile, like there is a from function here, and there is like exec, which looks like run. So the syntax itself is familiar from a Docker file. Actually, the guys behind Dagger are the same team that built Docker, so maybe that's the reason. But it's easy to move from an existing Docker file, if you have one, to Dagger code. And then you run the go build command, and you fetch a file. Obviously, this is within a container. You can fetch the build dependency and return it, add it to a container, or export it to your local file system, whatever you want. And you can do the same in Python, TypeScript. I believe now you can do it in Java and some other languages as well. How about AI? How can you use AI? So this example is one I mentioned before. It runs the tests for your software. And if anything goes wrong, it creates a new AI environment where it gives the error, the source code to the AI, and simply asks the AI to fix the test failures. And then returns the fixed code as a directory. That's another primitive that Dagger provides along containers and files. You get the final code as a directory that you can export to the local file system, which basically exports the files that the AI fixed and overwrites the ones that you have locally. And you can do this, obviously, in a CI pipeline as well. You can maybe open a pull request, but it's much easier to integrate AI agents into your workflow code this way than, for example, in GitHub Actions. You could do it. You could do the same thing in GitHub Actions, especially now that I think they provide models for you, so it's very easy to integrate with that. But it would still be pretty hard to build and test. So how it works under the hood, you write all these functions and you store them next to your project. And there is a CLI tool that you use, and it basically talks to a component called the Dagger engine. It runs in a container as well. And it builds a DAG from all of the Dagger primitives that you build with these Dagger functions and orchestrates all the containers. Well, at the time I created this image, it was only Docker, but now I think it supports a bunch of other, like Podman, Containerd, and a bunch of other container runtimes as well. But Dagger offers a lot more features. Obviously, the portable and programmable workflows is the biggest one, but you can also build reusable modules. So if you want to use the same logic across different projects, you can create a module and import that module into your project, so you don't have to copy and paste the same code into your pipeline. It also provides caching, so if you run it locally and you rerun it a second time, it's going to be much faster, mostly due to how containers work, like the layering in containers. It provides you with caching. It also integrates with secret providers, so you don't have to hardwire secrets into your workflow code, which is good because locally you probably use something like 1Password or some other password manager. In a CI, you obviously can use environment variables. And it also provides tracing, which is something that is missing, or personally, I miss this feature from all the major CI providers, because you can see which steps take the most time. Some of them give you that information, but you can't see how this changes over time. And with tracing and the aggregation that Dagger provides in their product, so it's a product feature, you can see how these things change over time and which step, how much time these steps take exactly. All right, so I think we have time for a demo before the questions. And I also have a surprise at the end, but I usually forget about it. So someone please remind me that there's a surprise as well. So how do I zoom in? Is it large enough, or should I zoom in more? Can you actually see it? Is it okay? Okay, cool. So let's see some actual code, how you build. Actually, let's go back to here. No. Here. Cool. So let's see some actual code that you can use to build your projects, and maybe this will be a better example to understand how Dagger actually works. So obviously you need to give the pipeline your source code. So in this case, there is a constructor that reads the source code into a directory primitive of Dagger and stores it in the struct, and then you can reuse it across different functions. Obviously, you could give these functions argument as well. So these are functions in every definition that you can call. So for example, you could pass a function or pass the source directory to the function as well. And then you mount the directory to a container. Again, this should be somewhat familiar from how a Docker file works. Run a bunch of commands and then extract the final artifact at the end. You can do the same thing for linting and running tests. And you can have, like, this is where the power of Dagger shines. Like, you can compose these functions into other use them from other functions. For example, if you want to create like a CI pipeline, you can write a CI function that runs all of these other functions to make sure that the application compiles, the tests run successfully, and the lint rules aren't violated. So in a CI, you could run this to make sure everything passes. Locally, you could run these separate steps if there is a problem with something to run that specific step and try to fix it. Okay, let's see how it works with reusable modules. So I have a Go module that I wrote. It's available on GitHub. And basically, it replaces that whole container mounting thing with some nice wrapper code. And it's also in Go, so you can use it in your Go functions. It initializes the Go module and basically just passes the source to a build function that gives you a final artifact, a binary. You can do the same thing with tests and linting, and the check thing is the same. So you can reuse these pieces of code that you write for your projects and create modules from them, and then reuse them in different projects. And the last thing I wanted to show you, obviously this is nice, this is the CI part. What about delivering some actual artifacts? So here is a build and a release function where you reuse the same build function that you use to, build a binary, test it locally. You can reuse the same build function and create a container that you are going to run in production. So it's a nice thing. You don't have to rewrite that whole build logic into in a different scenario. And then you can just build that container image. You can call this separately if you want, or you can run the container itself. We can actually try that. And then you can release it and push it, for example, to, I think I use GitHub, no, TTL-sh. But you can push it to a container registry very easily. So you can publish a container and push it to a container registry, which is nice. Usually, you probably don't want to do that. You would want to do that from a an actual CI release pipeline. But if it's down for some reason and you have to do a hotfix, it's usually a good thing to have. So let's see if I actually can run this. And while it builds, I don't know how much time it's going to take, or if it builds. Oops. So in the meantime, if you have any questions. Docker buildx. I don't think it works with that. Like you can build it, like you can write your own logic that mimics Docker buildx. Yeah, I know. Mm-hmm. I think so. Mm-hmm. Well, one thing you can do, and Dagger actually supports that. So one thing you can do, I think it's called Docker build. So you can run actually a Docker build from a directory. So that you can do. I don't think you can use Docker buildx, but Docker buildx is also a declarative solution, which is nice in a lot of scenarios. But you can easily rebuild the same logic in plain code that you. So it's a very thin layer over Docker files, so you can easily recreate it. Looks like it's started. Yeah, it supports that as well. So I think the Dagger team actually uses Go releaser to release their binaries. So you could rebuild Go releaser in Dagger if you wanted to. Well, trade-offs and limitations. There are no silver bullets. But you can build cross-platform or multi-arc images. Where is it? So in the publish section, I think here if... Sorry? So yeah, obviously, like if you look at the container image, it's building a container, but it also calls the build function, and this is actually runs asynchronously when you call these functions, and at the end, Dagger basically synchronizes the final artifact that you asked for, and it builds a DAG from all of these calls. So when you call the build function, it actually just returns an ID that you will use in this container. And at the end, Dagger creates a DAG of all of these function calls. Yes, exactly. And evaluates it at the end and runs all the steps it needs to do. Mm-hmm. How, like, how do you want to build an entire pipeline or? Oh, you can easily do that. So you can build that as a module and just call it. Yeah, basically use it not as a Go library, but yeah, you can build it in I don't know, Python, and you can call it from Go. That's a nice thing. Sorry, I forgot to mention that you can actually call cross-language modules because Dagger generates the necessary code for calling that module. in all of the languages that you use. So if you write a module in Python, it's going to generate Go code that you can use. And it's always going through the Dagger engine, which is an API, a GraphQL API actually. So it generates a client in Go, and then it's going to call the Python code, the Dagger engine. So you can write the module in a language you want, and then you can call it from whatever. Yeah. And the other thing you can do if you want to like reuse a complete pipeline is you can, for example, if you have it in GitHub, so you can call a remote module using Dagger call, which would be your huge pipeline. I don't know, call CI source local directory. So you could do something like this, and then your whole CI pipeline module would reside in a repository, and then you can just call that module with the local source. And there are a couple other options you have, but basically you can build your entire CI pipeline and reuse it across projects. Not in the open source version. In the cloud, there may be one, but lately it's been a bit buggy, so I'm not sure. If you want to see real-world pipelines, there are a couple repositories out there that use Dagger. Slides are going to be up on my website, so you can grab the links from there as well. But this last one is where all my Dagger modules are. The first one are real-life projects that use Dagger to test and deploy applications. So, any more questions? Oh yeah, the surprise. Thank you. So I have a little game for you. Try to guess which image was generated by AI and which was one created by myself. All of them generated by AI? You sure? So this was the first. So was it AI or did I generate it with a meme generator? So this is not AI generated. Well, I'm not sure about the flames, but this is actually AI generated. If you take a look at the number here and the fire hose here, that's a little bit different. So what I did, I basically gave the original image to AI and asked it to upscale it a little, and this is what it generated. All right, so next one. Did I create this or downloaded it or? Yep, this is AI. How about this one? By the way, do you know where this image is from? Okay, cool. Strangely, every time I do this presentation, everyone knows where this image is from, so.
This one I don't remember. That may be original.
That's a good question. So, is this real or?
Everything is fake today.
Yeah, so this is AI. I didn't like the original because it was a little bit low quality, so I once again asked the AI to generate a better one, and it's pretty good. Like the background is different, but it's pretty good. How about this one?
This may be from the GitHub action, so actually this may be real. Where's 59? Where's 50? They could be it's only for a few hours because I had similar for 7 days.
So is it real or AI generated? Okay. So it's not. So this is the original. Oh, I can't click it. But as you can see, there's a lot of gap between these. So I asked the AI to compress it a little. And if you take a look at here, for example, the commit hashes are a bit strange. So this is AI as well. And yeah. That's the tell. So this one, is it AI generated or? Can I? Sorry, I can't zoom in. So, it is AI generated? No, it's the only one that I created. All right, thanks a lot. Oh, I might have time.